In this video, we're going to be looking at elimination reactions, specifically dehydrohalogenation, which is just a fancy word for saying the removal of hydrogen and a halogen. So I've written here the general reaction scheme, and so we're going to start with an alkyl halide, and we're going to add a strong base. For this course, our strong base is going to be a hydroxide ion or something like sodium hydroxide. We will form an alkene as our organic product, and then water and our halide are going to be our inorganic byproducts. So you don't always have to write these down if you're not asked for them, but it's important to recognize what you're forming in case it changes things about the reaction. So I'm going to write a general scheme here for this reaction. I'm going to start with just something basic. So I'm going to start with chloroethane. So I will have a chlorine on this molecule, on this carbon. And then I will add in my strong base. So in this case, I'm going to add OH minus. So what's going to happen is my strong base is going to pull off a hydrogen on the carbon that is adjacent to the carbon with my halide. So these two are going to form a little bond together. That's going to give us the water. When that water comes off, we're also going to lose this chlorine. And when that chlorine goes, we'll form a double bond. So I'll draw the reaction mechanism on our next slide, but we're going to have hydrogen, carbon, and we'll have water and chloride. You'll notice here the geometry around our carbons has changed. So before our reaction, our carbons had a tetrahedral shape. They had 4 electron domains around each carbon. After the reaction, our carbons have a trigonal planar shape because there are now 3 electron domains around each carbon. So I'm going to walk through the general reaction mechanism here. This is not curricular. You don't need to know it for Chemistry 30, but it might help you understand what's happening in this reaction. So I'm going to draw a pretty simplified version. As you go on in chemistry and take organic at university, this mechanism will be fleshed out a little bit more. So I'm going to start with ethane, chloroethane, same as on the last example. So I'll have my chlorine and then my hydrogens. And we're going to add to this our OH group. So OH, and now there's lots of electrons around that hydroxide, and this is what we call a nucleophile. So it's looking for positive charge. And it's going to find that in a hydrogen adjacent to that chlorine. Because the chlorine is electronegative, it's going to pull some electron density from that carbon, or from that hydrogen. So this is going to attack that hydrogen. So the arrows show where the electrons are basically going. It's going to steal that hydrogen. Hydrogen's then going to basically donate its electrons to carbon. And it's going to donate them between the 2 carbons to form that double bond. And when that happens, we can't have a pentavalent carbon, so it'll kick out this chlorine. Chlorine's quite electronegative, so it can hold those extra electrons. So what's going to happen here is we will still have our 2 remaining hydrogens on our carbon. And we have water, which I'll write as HOH, and we have a chloride ion. So we've maintained our charge from both sides of the reaction. Our carbons all still have 4 bonds, but we've eliminated water from the reaction. So in this example, we're going to look at a situation where we could form multiple products. So I'm going to draw our alkyl halide, so chlorine there. We'll add our strong base, NaOH. Now, with this reaction, the carbon to which the chlorine is attached, so I'm going to highlight that here in blue, that carbon is going to be involved in our double bond. The carbons next to that carbon, so I'll highlight this one in green and this one in yellow, could also be involved in the double bond. These carbons must have at least one hydrogen. So this yellow one, I'm just going to draw the hydrogens in, has 2 hydrogens, and this green one, as it's a terminal carbon, it has 3. So both of those are possible to form that double bond. So we're going to have our pentane. If we form between the yellow and the green, we'll form this plus water plus NaCl. Okay, and the name for that, so we can verify if we're different compounds, is pent-1-ene. If we form a double bond between the blue and the yellow carbon, oops, super great, but that's okay. That double bond will go there. We'll form the same inorganic byproducts. However, this time our compound is going to be called pent-2-ene. So same reaction, however, 2 possible products.